Hello guys, in today's tutorial I would like to explain maximum likelihood method of estimation. Uh, we need to estimate different parameter in statistics as suppose we have population data and suppose that is the income of some specific age group, suppose that is from 20 to 60 in a country. So this is sometimes hard for us and particularly for students to collect the data from all these members and then calculate the parameter of the population. So in that case, you can collect sample. There are different sampling techniques. I will not discuss this in this lecture. Then you need to collect sample data from from some individuals, depend on their sampling design, and then you need to estimate those parameters based on the sample data. So maximum likelihood method of estimation. For this, for estimation, we need a sample data, and I denote this by suppose this is some observation 1, 2, and 3 up to n. So we have n sample points, sample data. Then we need to know about the distributions of the population. So this suppose we assume that this data is from some distribution, and we assume that these observations are independently and identically distributed, so that we can calculate the joint distribution. You can say, and when we observe the data, then we say that that is the likelihood function. So the likelihood function can be denoted by this likelihood function of the sample data and the unknown parameter theta, and this is the product of the marginal distribution of each observation. As I have these observations, so I can write the marginal distribution of x1, marginal distribution of x2, and marginal distribution of xn with the n parameter theta. And more compactly, I can write this product I from 1 to n and the distribution of x, I, and theta. And remember that for simplicity, I will write that the likelihood I will write by this notation. This means that this is the natural log of the likelihood function of the data. This means that this, when you see this symbols in my videos, you will see, you can understand, this should be understandable that this is the natural log of the likelihood function of the data. So now, okay, this is something basics about the distribution, the joint distribution and the likelihood. The difference between the joint distribution and likelihood is that when you observe the data in the joint distribution as likelihood function, there are two-step procedure to calculate the likelihood, the maximum likelihood estimate, or the MLE. The first step is to calculate the partial derivative of the log likelihood function. Remember that the log likelihood function and the simple likelihood function will give you maximum value at the same point. We take natural log just to make simplify the function. Remember this point. And now you need to calculate the first partial derivative with respect to unknown parameter theta, which is equal to this will have some value, and then you need to equate this to 0 to solve for the parameter theta. Now the question is why we equate this to 0. There is some logics. This means that you need to find, suppose this is a graph and this is the value of the parameter, and then this is the likelihood function or the likelihood function. So then you need to find the place where the slope is 0. The slope, because this is of course the slope. So the slope is 0 at the point, at the maximum and the minimum point. At the maximum point when reach here, suppose the parameter, the likelihood function reach here for some specific value of the parameter, it will be 0 here and then downward, and it will be 0 here at this point and then downward. So we need to find that place of the likelihood function with respect to the parameter where the slope is 0. So now at this point, this may be maximum or minimum, we are not sure in the first step. So remember that you need to complete these two steps in order to solve the question completely. I hope this is clear now. So this is the first step. In the second step, we need to calculate the second partial derivative. In the first step, when we solve first partial derivative and equate to 0, we will have some point for theta. And now, but we don't know that is maximum or minimum. In the second step, we need to calculate second partial derivative with respect to theta. This should be square. And then put the value of theta which you got in the first step, and if this function, the second partial derivative of the log likelihood function with respect to theta, given the value of theta equal to theta hat, that means the value you calculated in the first step is less than 0, then this point theta is equal to theta hat is maximum, and we can say that this value of theta is maximum likelihood estimate for theta. Okay, we can say that this value. Okay, so these are two-step procedure. Simply I will summarize this video tutorial that we learn in this lecture about the the likelihood function, the log likelihood function, and the two-step procedure. That means to calculate the first partial derivative when equal to 0 to solve for a value of theta, but we are not sure whether it is maximum or minimum. And secondly, we need to calculate the second partial derivative with respect to theta and check for the value of theta you got in the first step whether it is less than 0 or not. If it is less than 0, then this is the maximum value which you got in the first step, and then this is the maximum likelihood estimate of the unknown parameter theta. So thank you for watching.